Hi, welcome to this video. In today's video, I'm going to look at a very interesting problem of Math Olympiad. Okay, let P1 strictly inferior than P2, inferior than P3, and so on all the way down. Okay, sequence of prime numbers. The question shows that for any integer n, we have this product P1 through Pn inferior or equal to 2 the power 2n. Let's start solving this problem now. So as you see here, you have P1 through Pn. This is the product, okay? Inferior or equal to 2 to the n, okay? So we have P1 strictly inferior, P1 inferior or equal to 2 to the 2, okay? So this one is telling us P1 should be 2 because P is a prime number, so the P1 you will take the smallest number, okay? Let's try when n equal to 2. This implies P1 multiplied by P2 inferior or equal to 2 to the 2, okay? This one I can rewrite it 2 to the 4th, for example, or 2. This one I can rewrite it as 2 to the 4th, okay? So now, by induction, by math induction, climb P1 through Pn is true, inferior or equal to the n, okay? I'm going to prove P1 through Pn plus 1, P1 through to the Pn plus 1 inferior or equal to the 2n plus 1. This is what's required, okay? So this one, we have to prove this one in order to consider this one is true, okay? So now let's take a look first at here to see what is this one. So for example, let's put Q equal to P1 through Pn minus 1, okay? I will tell you in 1 second why I'm choosing this one, okay? I'm going to work on this one first. As you see here, P1, the product P1, P2. As you see here, for n equal to 2, we have P1, P2, inferior or equal to the 2, which is to the 4th, okay? If you take a look at here, I can rewrite this one as well. Since we know P1 equal to 2, because it takes a lowest number of the prime numbers, so we can rewrite it 2. I will have P2 inferior or equal to 2 to the 3. So now, what's this one telling me? So that P2, it can take 3 choices. It could be 3, it could be 5, it could be 7. Because this one is 8. Since we know P2 is a prime number, okay, is bigger than 2, is bigger than P1 equal 2, so we have 3 choices. So we have 3 choices. P2 can take three of them. So what does this mean? This one, the minimum of P2 equal to 3, the maximum of P2 equal to 7. So if you go back to this, if you go back to here, to this one, I will have for n equal to Q equal to P1 P2, right? Always minus 1 at the end. So this one, if I'm taking the minimum, so the minimum of P2 equal 3, the maximum of P2 equal to 7, right? So this one is always superior or equal to the minimum of this one. Okay, the minimum of this one, let's take the minimum as a 3, so let's multiply number 2 by 3 equals 6 minus 1 equal to 5. That means Q is always, that means Q is superior or equal to 5. Okay, for all integers. So I found a Q. Okay, the Q at least take 5 and up. So the maximum Q can take, for example, just I'm taking this example for the n equal to 2. Okay, so we found this one. So Q is always superior or equal to 5. Now what I'm going to do now, I'm going to work on this one in order to solve this problem. Okay, Q equal to, as we have before, we have Q1, Q equal to product P1 through to Pn minus 1. Okay, so let's so as you know here, Q superior or equal to 5. Okay, for all n. So this one, Q superior or equal to 5 if we have n superior or equal to 2. There is some number, there is a P is prime number such that P divide Q. Q is a product of P1 minus 1. Okay, climb P different not equal P1 P2. I'm going to prove this P is not from P1 through Pn. Okay, P is a prime, and then also P1 P2 are prime numbers as well. Okay, so since P divide Q, what does this mean? This means Q is a multiple of P. Okay, I can write it on this way. So this means 1P, 2P, 3P, and so on. Okay, n minus 1. It's 1Pn minus 1. Okay, so I'm going to bring this np to the other side. I will have the np to the other side. I will have P1 through Pn equal to 1. Okay, so let's call this one capital A. Okay, what is this expression? This is Bayes' theorem. What does this mean? This means GCD of A P equal to 1. Okay, that's mean P not divide A, capital A. In the other word, P not divide any of these primes, P1 through Pn. That's mean P is not available as a prime. That's mean P as a prime number is not available in the list of these prime numbers, P1 through Pn. Okay, this is the claim that I have. So this one is true. Okay, so that's mean P1 not through this one, P1 and so on. Okay, the p is not multiple of these numbers. Okay, so since we know p is not a variable in the list of prime numbers as you see here, okay, so that means there is no multiple of this prime number among this list of prime numbers, so we should find it. Okay, since we have this sequence is as an increasing sequence, p1 is less than p2, less than p3, and so on, we can find. So that's mean since we have p1 inferior p2 and so on, pn and pn plus 1, increasing sequence, increasing sequence is telling me p should be bigger, at least is taking this value. Okay, since we have p is an increasing sequence, so and then also p as a prime number is not available in this list, that's mean at least this prime number has to be superior or equal to pn plus 1. At least you're gonna take the minimum value pn plus 1 and up. Okay, also we know p divide q, q1, q2, and kn minus 1. We know this formula. Okay, since we know q is a multiple of p, okay, it's equivalent q over p equal to m superior equal to 1. Okay, the m at least you take number 1. This means m could be 1, 2, and so on. What does this mean? This means q through pn minus 1 superior or equal to p, as you see here, and also we found p is superior or equal to pn plus 1. Okay, pn plus 1. I'm going to flip this inequality, so that's mean pn plus 1 inferior or equal to p inferior to q. Q, as you know, q is a p1 p2 through pn minus 1. Okay, what does this mean? By induction, so by induction, as you see here, we have p1 p2 through pn inferior or equal to 2n, because we suppose to this one is true, we claim this one is true. Both this one, what this mean? This one, that's mean pn plus 1 inferior or equal to q, which is p1 through pn minus 1, which is less than this one, 2 to the n minus 1. Okay, this one, that's mean pn plus 1 inferior or equal to this one, that's mean pn plus 1 inferior or equal to the n minus 1. This one is inferior to the n. Okay, this is very important. Okay, 1 through pn inferior or equal to the n. Okay, also we found p1, we found pn plus 1 inferior or equal to the n minus 1 inferior to the n. We'll have p1 multiplying inequality number 1 by inequality number 2, we'll have P2, P1 through Pn multiply by the Pn plus 1. Okay, I will have this one. I will have 2 to the n multiply by 2 to the n equal equal 2 to the n square, which is 2 to the n, which is 2 to the n plus 1. Okay, that's mean the product of pk, k goes from 1 to the n plus 1, okay, equal to P1 inferior, strictly inferior than 2 to the n plus 1. Finally, the product P1 through Pn is inferior, strictly inferior than 2 to n. Okay, this is the proof of this problem. Okay, this is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.